Okay, here we go with part 2 of our notes on translation. We're going to write a rule for a translation and also look at what composition of transformations means. So to write a translation rule, this is where we're given the pre-image and the image points, and we have to figure out what was done to go from the pre-image to the image. So we want to know the coordinates of the vertices of both figures, so we'd want to make a list. So for got it number 4, we have a list here. Okay. Our pre-image was triangle LMN, coordinates -6, -1, -4, -3, -1, -1. We want to find the algebraic relationship between the pre-image and the image. So we can just use one set of coordinates to find this. So if we just pick our first pair, to go from -6 to +1, we had to add 7 and then to change the y coordinate we went from -1 to -2, so we subtract 1. So our translation rule would be x plus 7 y minus 1. You could also write it in what's called vector notation. We just do 7, -1, and that tells us what to do to the points. You can also graph those to make sure you did it correctly. So we'll graph both of these and make sure we did this right. So -6, -1 is L. -4, -3 is M. And -1, -1 is N. And then our image is 1, -2, 3, -4, and 6, -2. Remember, when you do the image, you need to put the prime notation, that little apostrophe, so that you know which was your pre-image and which was your image. So this is the pre-image. This is the image. And if you look at our points, we can maybe take point M, because that one's pretty easy to do. So we can just double check. So we went over 1, 2, 3, 4, 5, 6, 7, and down 1. So our original M is down 1. So add 7, subtract 1. And we've done that correctly. Last but not least, we can combine transformations, so a combination of 2 or more transformations. In a composition, you perform each transformation on the image of the preceding transformation. So we kind of go backwards. And the composition of any 2 translations is simply another translation. So for a really good example of this, you can look through problem number 5 on page 574. And also do got it number 5. Okay, let's talk about the got it question. If you looked at problem number 5 on page 574, you'll notice that after we moved the chess pieces, the original chess piece was 6 to the right and 2 units down from where it originally started. We want to make yet another move, 3 left and 3 down, and we want to know how far is it away from its original position. So we can continue our math on the point where we left off. So if we're going to go from positive 6, okay, which is 6 to the right, now we're going to go back 3 to the left. So that would leave us in a position of having added 3. It's the original position. So we went to the right 6, but now we're going to the left 3. So that leaves us 3 to the right from the original position. And now we want to move 3 down from here where we left off. So 3 more down from y minus 2 would be y minus. So from its original position, it went to the right 3 and down 5.